Alright, what's up guys? Here's the last part of polynomial operations before we go into division. We've done adding and subtracting in the previous videos. This is multiplication. Now when we multiply polynomials, we use what's called the box method. So let's look at how the size of our box changes based on what we're multiplying. So in this first example, we're multiplying a two-term polynomial. Look, 1, 2. This is two terms. And we're multiplying by another two-term. That means when we draw our box to set up, we need to have a 2 by 2 box so our polynomials fit. So we would put our 2x and our minus 4, and our negative 3x and our 2, and there's one space for each term. Now if our polynomial gets bigger, here we have 1, 2, 3 terms times another polynomial with 3 terms. So we need a 3 by 3 box. That way our polynomials fit 3x squared minus 4x and 2, 6x squared, our 2x, and our minus 4. There's a spot for each one of our terms. Now, here's what's different. Now, what's really nice is multiplication. It does not matter if you have like terms. Your terms do not have to have the same variables and the same exponents in order to multiply. For example, if we're multiplying, 2x squared and we're multiplying it by 4x, these aren't like terms. You can't add them together, but you can multiply them. When you multiply them, you have to be careful. You multiply the numbers in front. 2 times 4 would be 8. Now, which variable would I write? So this is the tricky part about multiplication. You need to look at your variables. Here I have an x squared. That means there are 2 x's. The second term, the 4x, had 1x. So altogether, I had 2 x's with the 2 and 1x with the 4. So altogether, I had 3 of them, x to the third. So that exponent is going to change when you start multiplying. When we add and subtract, this didn't change. When we multiply, it will change. Okay, so we got some examples to take a look at. Okay, example 1. First thing we need to figure out is this is a 2-term times another 2-term. So I need to make a 2 by 2 box. So off to the side, I'm going to draw a 2 by 2 box. Okay. It doesn't matter where your first polynomial goes. I'll just write it on the top. 8p and minus 2. 6p and positive 2 on the side. And look, make sure you bring the negatives with. Okay, so first box, 8 times 6. 8 times 6 is 48. And here's where I have to be careful. I have 1p here and 1p here. So there's 2 p's, so p squared. Okay, next box. 6p times negative 2 would be negative 12. And I had 1p. And I have 8p times 2. 8 times 2 is 16. And again, look, I have 1p. Last box is 2 times negative 2, which is negative 4. Neither of my terms had a p, so no p. Okay, all we have left to do is write our final answer. And now a lot of times we have to see in our box, I have a p squared, I have a couple p's, and I have one naked number. 16p and negative 12p are like terms. So when we want to write our answer, we want to make sure we add them together. So I have 48p squared. It didn't have any like terms. And I'm going to add these two together. These are like terms, so I'm going to add them together. When I add these together, I get 4 plus 4p and then minus 4. And I'm done. All done. Okay, just so the video is not super long, example 2, why don't you try on your own? Try on your own. It's exactly like the first example. I don't want the video to be too long. Okay, example 3. This time we have 2 terms and a 3 term. So I need a 2 by 3 box. So I want my box to be 2 high and 3 long. Like this. Okay, so I have my 7k and my negative 3. And then I have my k squared minus 2k plus 7. Okay, so I have one spot for each one of my terms. Starting with my first box, which this k squared has a 1 in front. So 7 times 1 is 7. And now I have to keep track. I have 1k here. I have k squared, which is 2k's there. So altogether, k to the third. K to the third. My next box, 7 times negative 2 is negative 14. I had 1k, 2k's, so k squared. And then I have 7k times 7, which is 49, and there was 1k. Bottom row. 1k squared times negative 3 is negative 3. I just had a k squared. Negative 3 times negative 2, careful, negative times a negative is positive 6, and I had 1k. And 7 times negative 3 is negative 21. Okay, so this time, when I'm writing my answer, again, I'm going to look for like terms. I have a k squared and a k squared. I have, meant to go blue. I have a 6k and a 49k. Okay, so two pairs of like terms. I'm going to make sure I add together when I write my answer. So I have 7k to the third. When I add these two, I get negative 17k squared. 6 and 49 makes 55. And negative 21 at the end. And we're done. So I combine those like terms when I'm these like terms when I'm writing my final answer. And you always do want to try to make sure your exponents go from biggest to smallest. Okay, last example, example 4. Okay, example 4 is a big one. It is a 3 by 3. So we are going to need a nice big 3 by 3 box. Do your best. 3 by 3. Okay, so I have my 6n squared minus 6n minus 5, 7n squared, 6n minus 5, and we start multiplying. 7 times 6 is 42. I have 2 n's, n to the fourth. 6 times 6 is 36. 2 n's here, 1 n here, so n to the third. And 6n squared times negative 5, negative 30. I had an n squared. Okay. Negative 6 times 7 is negative 42. 2 n's up here, 1 n here, so n to the third. Negative 6 times 6 is negative 36. 2 n's, so n squared. And negative 6n times negative 5 is 30. I had 1n. Okay, how are we doing? 7 times negative 5, negative 35. I had an n squared. If negative 5 didn't have any. 6 times negative 5 is negative 30, and it had 1n. And negative 5 times negative 5 is positive 25. Okay, now we have lots of like terms. We have 2 with n squareds. We have 3, or n to the thirds. We have 3 with n to the second, so we'll have to add all of those together. And we have 2 with just n's. Okay, so I'm just going to start putting these in order. I have 42 n to the fourth first. Okay, add together my next two, these two right here. Okay, negative 42 plus 36 is negative 6. N to the third. Okay, I'm going to add all three of these together. Negative 30 plus negative 36 plus negative 35 is negative 101 n squared. When I add my next two together, these actually cancel each other out. 30 and negative 30 make 0, so they're gone. And plus 25 at the end. Okay, this is how we multiply polynomials. Okay, box method, make sure you're careful about your variables. Your variables a lot of times change when you're multiplying. All right, thanks, guys.